All right, let's talk about one of those classic GCSE maths problems that can really look tricky at first glance, the incomplete histogram. But trust me, once you see the method, you'll realize it's actually pretty straightforward. So here it is, question 16 from a past paper. We've got this histogram showing how far 60 teachers travel to school. But as you can see, there's a problem. A couple of the bars are just, well, they're missing. So the big question is, how on earth do we complete it? Well, the good news is that everything we need to solve this is already right here. It's kind of like a little puzzle. And by the time we're done with this, you're going to know exactly how to crack these every single time. So, you ready? Let's get into it. Okay, first things first, before we even think about touching that graph, we need to talk about the one golden rule of histograms. This is the key that unlocks pretty much every single one of these problems. And here it is, frequency equals frequency density times class width. Now, that might sound a bit complicated, but it's actually super simple. Think of it this way. The area of each bar is the frequency. That's the how many. In this case, how many teachers. The frequency density, that's just the height of the bar. And the class width, that's simply how wide it is. This little formula is what lets us translate the picture into actual numbers. All right, let's decode the data. Now that we have our golden rule, it's time to put it to work. The best strategy here is always the same. Start with what you already know. Let's figure out the stuff we can see on the graph right now. Just a quick heads up, we're using the exact numbers from the official mark scheme. This just means the solution we're about to build is the perfect way to get full marks. Okay, let's take a look at the bar for distances between 10 and 20 miles. So its width is just 20 minus 10, which is 10. Easy. And if you look at the vertical axis, its height, the frequency density, is 1.5. So we just multiply them. 10 times 1.5 gives us 15. That's 15 teachers. Right, let's do the next one. The last bar on the graph from 30 to 50 miles. The width is 50 minus 30, so that's 20. The height is 0.5. You know what to do. 20 times 0.5 is 10. Boom! Another 10 teachers accounted for. See? Simple as that. So let's just pull all that together. We were given the 15 teachers for the 0 to 5 mile group. We just figured out there are 15 teachers in the 10 to 20 group and 10 teachers in the 30 to 50 group. This is huge. By just working with what was already there, we filled in most of the puzzle. All right, now for the fun part. Let's find those missing pieces. So how do we do it? Well, it's a really clear three-step process. First, let's add up all the teachers we've already found. 15 plus 15 plus 10. That gives us 40 teachers. Now, we know the total is 60, right? So we just do 60 minus 40, which leaves us with 20 teachers. And remember, the question said those two missing groups are equal, so we just split that 20 in half. 20 divided by 2 is 10. There you have it. So this means there are 10 teachers in that 5 to 10 mile gap and another 10 teachers in the 20 to 30 mile gap. That's the breakthrough moment. We've taken those empty spaces on the graph and given them a solid number. We're so close now. Okay, so we know the frequency for our missing bars is 10. But how tall do we draw them? Well, we just go back to our golden rule and flip it around. If frequency is FD times class width, then frequency density must be frequency divided by class width. So for that 5 to 10 mile bar, the width is 5. We do 10 divided by 5, giving us a height, a frequency density of 2. And for the 20 to 30 mile bar, the width is 10. So we do 10 divided by 10, which is 1. Perfect. And that's pretty much it. We have all the data. It's time to put the final pieces of the puzzle into place and finish this thing. So here's the whole shebang, all laid out in one table. You can see our missing numbers slotted right in there. All that's left to do is draw them on the graph. The 5 to 10 mile bar gets drawn up to a height of 2, and the 20 to 30 mile bar gets drawn up to a height of 1. And just like that, our histogram is complete. Okay, so what did we just do? Let's boil it all down and turn this into a handy little toolkit that you can use for any of these questions. It's basically a 4-step method. 1. Use the formula to work out the frequencies for the bars you can already see. 2. Add those up and subtract from the total to find out what's missing. 3. Flip the formula around to find the heights of those missing bars. And finally, step 4, draw them in. It's a really solid method that'll work every time. So there you have it. That's how you crack an incomplete histogram. But it makes you think, doesn't it? This whole strategy of find what you know first to figure out what you don't. Where else could you use that? What other kinds of problems could you solve with that exact same logic?